I'm Benz, cloud advocate at Microsoft, and today I'm going to talk about making container apps smarter with sidecars and actions. So I'm going to use Dapper for this, but I'll explain what sidecars are and a few other things as well. This is something that's kind of cool and relevant, I find, for the Java community at least, and others as well, but mainly Java because we have a lot of legacy applications. And the advantage of having a sidecar is you can just add functionality. Oh, the mic's not on? Oh, I got to turn on, yeah. It's been a while since I spoke in person. It's funny. Okay. Am I on now? Can you hear me? No. Okay, hopefully there. Yeah, okay, cool. All right. So, yeah, basically what I was saying is, sidecars are really relevant for Java, I think, because there's a lot of legacy applications you don't want to touch. And this is a way to actually add functionality to those applications with little or no code changes. So it's kind of cool stuff. So what's a sidecar architecture? We've got a bunch of standard APIs running on Dapper. So Dapper is an open source project. It's dapper.io, dapr.io. Microsoft is the corporate custodian of it, but it runs and works with Azure, of course. It also runs with Google and with Google's cloud and with AWS as well, and runs on a variety of architectures. And I'll get into all that. But basically, a sidecar architecture is where you take the code that you don't want to touch in your application, and you add cool things to it, like service invocation, state management, pub sub, resource bindings, actors, distributed tracing, and other stuff. So I've only got 9 slides for this, and then we're going to do the rest in demos. So Dapper can run on all of these languages, so Go, Node, Python, .NET, Java, functions, and it's also extensible. So if you have another platform or language that you want to work with, you can add to the framework as well with custom extensions. As I mentioned before, we got service invocation, state management, and several other things. And what are these things? I'll get into that in a second. What problems does Dapper solve? Basically several. So as I mentioned before, you don't have to touch your original application to add a bunch of functionality to it. And or if you have polyglot applications. So you might have an application that runs some Node, some Java, things like that, and you want to share a state store, for example. You can do that very easily with Dapper, and that's what I'm actually going to show in my demo today. It's calling service endpoints, so basically we're standardized on either HTTP or gRPC. Who knows what the G in gRPC stands for? Something I had to look up. Go for it. It is Google, yes, well done. So 2015 gRPC it's a remote procedure call. Google Remote Procedure Call is what it stands for. It's in 2015, it was donated by Google as an open source project. And it's just a way of accessing endpoints in different applications without going through HTTP. It will actually uses HTTP too, but you don't have to have web access to access it. Then any kind of stateful microservices that you're using for configuration, consistency, et cetera, especially in a polyglot application. You can use one, sorry? It's turned off again. Oy. Okay, can you hear me now? I don't know if the battery's dying or what. Apologies. So basically, yeah, let me know. Let me know if you can't hear me because I can't tell up here. All right, so yeah, basically, if you're using polyglot applications, you want to access state management or other resources, pub sub, or if you need to trigger a service from somewhere else using a standard protocol, you can choose Dapper in this case and a sidecar, and you'll be able to access it from all of your applications, regardless of what language they're written in. So that's kind of the advantage. Again? Okay, where's the kid? I'm not sure. Hold on a second. Can you hear me? Yeah, I think the battery's dead. Just a sec. We have time. Let me see what we've got here. I think there was a kid in the back. He stepped out. We have a backup. Does this work? That works. Okay. I can improvise. We can do this. Sorry about that. Let me mute it. When you're doing live presentations, you never know quite what you're going to need to adapt, but this isn't one of the normal ones. Usually your code's failing. What the hell? Anyway, not mine, of course. All right. Can you hear that okay? Yes, good. Okay. So hopefully the other one's working. I don't even know. All right, so basically you've got a whole bunch of capabilities you can add to your applications. Here they are, and I'll move on. So the microservice building blocks, I talked about these a couple of times now. These are what they are. So state management is a way of actually managing the state of an application, writing something. You know, if the typical one is a shopping cart, so you have information about a certain shopper, and regardless of what application they're using or where they are on a website, it stores the information so it's consistent, so they don't have to log in and start over just because they moved from one part of the site to another. And then you have service invocation and fault handling. In that case, you know, also known as resiliency, and being able to recover from a failure and being able to queue up state and any other things that need to be stored in your application while a service might not be available. So when you work with microservices, this is a common problem. For whatever reason, network or back-end services, something goes down and you don't want to lose all the information that's being processed on the front end in between the service going down and coming back up. All right, so resource binding as well, just being able to connect to things without having to write your own code for that. PubSub, scalable messaging, so that is related to service invocation and resiliency as well. And then actors, so actors is a way to actually use objects that you can create and manage, and those can be in polyglot applications as well. So you can create an actor in .NET or Node or Ruby or anything else, and then it would still be able to be invoked in Java or something else because you've done it through the Dapper runtime. And then it builds in Zipkin, so you have distributed tracing and diagnostics as well when you're using Dapper in the sidecar. So what does that look like? State management is the one example I'm going to use today. And basically you post something and it stores it. In this case, it's going to store it in Redis. And you can retrieve information from that Redis store through Dapper, and the original application doesn't know what your back end is. You're storing the state in. You could even change it during the runtime of the application, and it'll still function between different applications. So Dapper self-hosted, basically you run Dapper init, which runs things locally, and that could be on a VM or it could be on your local machine, as I'm going to show. And that creates a whole bunch of resource bindings and everything that you saw there in terms of the capabilities and the add-ons that you have for your sidecars in Dapper. Kubernetes gets a little more complicated because each one of the components that I showed you, the state management, PubSub, have to be invoked separately. And those run in their own individual pods, and that way you have control over which ones of the applications are running. It's just a little bit more efficient for Dapper and for your end user applications. You don't want to have PubSub running unless you need PubSub in your application. When you're running it locally, it just gives you everything. So how that works is each pod, you've got a Dapper placement as your Dapper runtime. You've got an operator, and you've got a sidecar injector that runs with your application as well. Then you've got a container sidecar. HTTP or gRPC goes to your actual code, and the sidecar handles all the PubSub, state stores, input-output bindings, or anything else you have in your application. Okay, so let's do the demo. So I'm going to show two things today. I'm actually going to show you self-hosted first, and then I'll show you the Kubernetes. We're going to deploy to Kubernetes, and then after that, we are going to I'll show you how to create an action in GitHub that if you have any changes to your code will actually push your code back out to your Kubernetes instance as well. But we're going to do it manually first. So let's do this. So this is Visual Studio Code. How many folks use Visual Studio Code for Java? Just a few? Okay. Yeah, cool. I always like to take a show of hands. We never know quite what people use it for. You don't have to use it all the time for Java. I'm just curious if folks are using the Java tools that we built. All right, so this is my demo steps, basically. It's so I don't miss any steps as we go through this. We've got a couple of windows down here running. This is a Windows machine, and I'm running Windows Subsystem for Linux, aka Linux on Windows. And it's an Ubuntu implementation. And I've got some Java code, some YAML, and some other things I'm going to show you here. All right, so let's start. First thing I'm going to do is, I think I've got this set up. Yeah, I changed the directory. I installed Dapper. I did a clean install already. So I'm going to do a Dapper init. And what that does is it actually creates all the Dapper I need on my local machine to run Sidecars, basically. And that's all you need to do. It takes a second. It downloads some binaries from some containers, et cetera, et cetera. And when that's done, got a slow Wi-Fi here. Yes. So it says success, Dapper's up and running. So now I can run my application. And my application really is a pretty simple Java app. It's just called orderprocessor.java. Yeah, for those of you back, I apologize. I can't make the screen any bigger because I've got some multiple windows that are going to run. So anyway, it's just basically it counts. It simulates an order. It writes it to Redis, so client save state Dapper state store. That's an envar that's been created when I started up Dapper just now. It's going to save an order, and then it's going to delete that order so it doesn't take up too much of my Redis. And if anything goes wrong, it's going to give an error message here that tells it that Dapper has had problems with state store, but I'm going to start. So what I'm going to actually do is I'm going to kill Redis on this application, and then I'm going to start it up again, and you'll see that it picks up where it left off. So it handles resiliency. This is all the code I have. And Dapper handles the rest. Dapper handles the writing to Redis, and it handles the resiliency to recover from the downtime in the application itself. All right, so let's see here. Oh, one thing I want to show you. So this is my Docker. Let me see if I can make this bigger at least. Nope. So for those of you in the back, I've got Redis, I've got Dapper, and I've got a Zipkin container running on my local machine. This is what happens when you do Dapper init. It fires up all these services for you and initializes them. All right, so if I go ahead, run the application, and in order to start the application, I don't do Java jar. I say Dapper run, first of all, and I choose the app ID, which is order processor, and then there's a path to some resources, and then we start Java jar and the actual jar file. So Dapper is running, and it's containing the Java runtime for us. So anyway, I'll just start it up. Bum, bum, bum. Whoops, what happened? I don't think it ran. Yeah. So it's actually going to start, it's writing the orders. Okay, so what I'm going to do now is I'm going to go to another window here, and I'm going to stop Docker. And you're going to see over in the other window, oops, did it stop it? Thank you. What happened? Went up. Docker, stop Dapper. Okay, There we go. Now over here, it's telling you there's an error. It's going to retry. And it's telling me the circuit breaker has broken. So it's saving, it's leaving it, and then it switches to half open. It starts doing half open to check to see if things are available again. And then I could go here. I'll do Docker start. All right, so start. And there we go. We picked up where we left off. So we were on the order. Anyway, we're on 39 now. It just picks up where it left off. And it continues to process the orders until it gets to 100. So that's the idea behind Docker and the resiliency. I didn't have to code anything except this application here, order processor, which just basically writes and reads to a Dapper state store. All I need to know from my application is what's the Dapper state store envar I'm going to use. And Dapper took care of the rest. And when the Redis went down, I was able to restart it, and it picked up where it left off and continued processing the orders. So pretty cool stuff, I think, in terms of running things without having to change your core applications. So as I mentioned before, that's the advantage of having these sidecars is you can do cool things. There's all kinds of bindings available. In this case, it's a really simple Redis example with state store and resiliency. But there's other bindings in Dapper as well. There's hundreds, and you can actually have external bindings as well to services like all the social media apps and things like that too. So that's kind of cool. All right, so let's get this out to Kubernetes. So as I mentioned before, that's self-hosted. So everything is available when you're running it locally, starting Dapper init. So when you go to Kubernetes, it's a little more complicated setup you have to do. You have to invoke a Kubernetes instance. In this case, I'm going to use Azure Kubernetes Service, which is Microsoft's Kubernetes service. And then I'm going to invoke certain bindings and certain services that I want to use on Dapper, each in their own individual hubs. I've already set up most of this, and then what I'm going to do is deploy the Java app. So the pods themselves have already been set up. The sidecars there. And what I'm going to do is deploy the Java app into the environment. And then I'm going to kill Redis again through just stopping a pod. And you'll see the same behavior that you saw locally when you do that. All right. Let's stop this now. I'll stop that because I got to use that. All right. So for this, what I'm going to do, I use the Azure CLI to create the environment that I've got for this application. And if I go over to my browser here, you'll see, so this is an Azure portal, portal.azure.com. If you don't have one already, you can get a free trial if you go to portal.azure.com. What I've done is create a Kubernetes service. And this, by the way, I'm using Azure Kubernetes service, but it could be any Kubernetes service. It could be one running on AWS or Google, or your own Kubernetes service running on a VM or locally as well. In this case, it was easy for me to set up. And of course, I work for Microsoft too. So I set up a container registry, which is like Docker Hub for storing containers and then deploying them. And then I set up a Kubernetes service. And the Kubernetes service itself, Microsoft manages the control plane. So all the management of the Kubernetes cluster, and then you manage the pods and everything else. And you can manage your services and things, but it actually provisions VMs on the back end. And by the way, those VMs can be Intel and or ARM. We have some ARM VMs that run in our AKS service as well, so that's kind of cool. So those are the two things I've got. So what I need to do is I need to deploy this application to my container registry, and then I need to run it on Kubernetes. So to do that, what I did is whenever you create anything in Azure, you have to create a resource group, and that groups everything together. That's that little square you see here. So this square here is my resource group, and these two things are in it. So you say AZ group create. This is the Azure CLI. It runs on Windows, Mac, and Linux. It's written in Python. And then you say AZ ACS create. That's the Azure Container Registry. Actually, so it should be ACR create. I don't know why that's there. The AZR is, the ACR is your Azure Container Registry. It's a private registry that I create. And then I say, I change the directory. And this is the Docker file that I have. It's right here. It's pretty simple. It's just from Maven 3.6. JDK 11 is build. And then you just do a Maven clean install. And when you do the Maven clean install, I should show that actually. So inside the pom.xml, we have dependencies. We have Dapper, we have Project Lombok, and we have a Spring framework. So it's a Spring Boot application. That's all we've got. It's a very simple application. And Dapper adds all the other stuff on top of that. So when you just invoke Dapper as a dependency, it adds all of the state management and makes that setup for you. So the Docker file itself, I should show the rest of the Docker file. So the rest of the Docker file, once you do the Maven clean install with Dapper as a dependency, then you use the OpenJDK JRE Slim, and that is a small application. It's not a distroless application, which is where there's no operating system supporting it. It's a very minimal operating system, in this case Ubuntu, supporting the application. And then you have a runtime, of course, which is a jar file. So that's the Docker file that you use for this. I keep switching tabs when I don't need to. There we are. So that's the Docker file. So you do AZ ACR login. That's the Azure Container Registry. You log into the registry. And then you do, this is kind of cool. This command is AZ ACR build. And what it does is it actually creates, it's like doing a Docker build and a Docker push all at once. It takes the code that you have locally, in this case on my local machine, and it pushes it up to something called a hosted agent. The hosted agent itself is where you actually do the build of your Docker, and it's got a whole bunch of software built into it. And the build itself, if it's successful, creates a new item in your container registry. So let me show you what the result of that is when you do the ACR build. It takes a few minutes, depending on your Wi-Fi, to actually package everything up and take it up. So I've already done that part. If I go into my repositories, you'll see I have the V1. These are all from the action, by the way. I'll show you that in a little bit. But V1 is the actual item that we created. So we did the AZ ACR build. That did the Docker build and the Docker push, and it created an entry in our repository in our container registry. And everything's there. It's ready to go. So now I can actually deploy this to AKS. So what I do there is I create a Kubernetes service, and that's just this command, AZ AKS create. And it creates the new Kubernetes service, and it attaches the Azure Container Registry that I created. So the Kubernetes service will be connected to that registry, so it knows where to look for containers when it wants to deploy them. But I've got another way to do that as well, which I'll show you in a minute. And then you do an AZ AKS install CLI. That installs the Azure CLI onto, the kube control CLI onto your Kubernetes instance. And then you get your credentials. So AZ AKS get credentials sets up your local credentials. So when I type kube control commands from my local machine here, it knows which Kubernetes instance to work with. In this case, the AKS creation that I built already. Next thing I do, there's a couple of registrations I have to do, because that's just vanilla AKS, right? That's just vanilla Kubernetes sitting there waiting to run a container, but we need to add Dapper to it. So there's a few things you need to do, and by the way, these are available through a doc here, but I have this shared in the repo as well. So AZ feature register, so you have to register an extension manager in your Kubernetes, and then you register as well Dapper. So that actually creates a registry for Dapper inside your Kubernetes instance. Then you can check it through this status. This takes about 15, 20 minutes. So once again, I pre-created that. And then you do AZ provider register. You set up a container registry in a service, and you add an extension that you need for building Dapper. And this is actually the main command here. So this is creates an extension, and it creates a cluster which manages all of your Dapper application runtime that you have. It also sets up what's called a principal ID, which allows for authentication between Dapper and all the other things that you're going to run on this Kubernetes service. So that's very important as well. And by the way, you run this on any Kubernetes that you're going to be using, because it needs to be set up, obviously, to not only run Dapper, but have Dapper be able to communicate with all of the services and runtimes that you're going to build into this. So that's the response you get from that. And then you can say kube control, get pods, Dapper system. So as I said, I've already done this. And this is what you get when you got that. So I've got everything running here from my Dapper. I've got a placement server. I've got operators. I've got a dashboard that I can use. The sidecar injector is what we're going to use to do the resiliency and the state store. So everything's up and running there, and it's ready to deploy an application. I can also do a Dapper status K. Whoops, no. What happened? Go away. Yeah, so Dapper status K gives you the operator, the dashboard, the injector, and a few other things running as well. So it's just a different way to look at it. So the next thing you do, and this is where we're actually going to get into setting up the application. So in this particular application, you're using a state store, which is Redis, and you're using a resiliency service on Dapper as well. And those are controlled two different ways. So in Helm, you have to do Helm install Redis, and it uses the Bitnami image of Redis. And by the way, the hardest part about this is installing Helm 3. I don't know if anyone has ever done that. If you're using Helm 2, there's a new version, which is Helm 3. And don't worry, set aside about a weekend to make that work. But anyway, it's just a heads up. You have to use the latest version of Helm. If you don't have Helm installed, that's fine. Just install Helm 3. If you have an older version of Helm, it's actually a little bit hellish to get it upgraded. But anyway, that's a fair warning to you folks if you're using that. All right, so you use Helm. So Helm installs the Redis service that you're going to use. And then you say kube control apply, and you deploy a Redis service on top of it. So it defines exactly what you want to put in your Redis service. And then you kube control apply resiliency. These are two pre-made YAML files. So in this case, Redis just installs Redis as a pod in your application. This installs the resiliency service, and it tells the resiliency service what to do. In this case, watch forever, basically. Every 2 seconds, check to see if something's working. If it's down, retry it as many times as you need to. And you have a circuit breaker, in this case, the simple circuit breaker built in. The maximum requests are going to be 1. That's for each retry. So each retry is going to be 1 request. There's going to be a timeout of 5 seconds, and if it's a 5-second, then it trips the circuit breaker if it can't access the Redis store. So basically, that's how that works. It's going to retry forever, and it's going to run. So it's going to simulate what we showed locally. When I stop the Redis container locally, it's going to trigger the circuit breaker and run almost the same way that it did before. All right, and then the next thing we need to do is we need to apply the Java. So the Java itself is here. So the Java app, it's called. There's a name and a namespace called Java app. And there's just one replica of it. It's going to match labels for Java so that Dapper knows this is a Java application. And then this is the source where you actually get the application. Remember, I said there was two ways that you could actually access the application. When you create the Kubernetes service, you can connect the registry to it, but you can also, inside this YAML here, tell the application via the YAML, tell Kubernetes where to find the container that you want to deploy out. So that is the steps that you need to do to set this up on Kubernetes. Seems like a lot, but trust me, if you had to create Kubernetes from scratch and then build your own sidecars for resiliency, et cetera, you'll have more than just this code to work with, and it is a lot more complicated. So this is a nice standardized way and relatively easy way to deploy this onto Kubernetes, believe it or not, even though there's a lot of steps. All right, so the first thing we're going to do, I'm going to set up 3 windows, and for those of you who were here earlier, this is the part where I was warning that I'm going to have 3 windows that are going to be running, and they're going to be sort of small, so I'm going to close this down. And so you'll see different things running. The first thing I'm going to do is I'm going to set up the first window, I'm going to have the Java application deployed to Kubernetes, and that's going to start running just the way you saw it in the local demo. And then the next one, I'm going to have the Dapper logs running, so you can see what's going on there. And then the third window, I'm going to delete the pods that we had for Redis, and that's actually going to allow us to show you all the resiliency capabilities in Dapper with Sidecar. So get pods. In this particular situation, what we've got, after we've got all that set up, all we have running is, let's try that again. There we go. So we've got a Redis master, and we've got 3 replicas of Redis. So we've got redundant Redis running, and the master is what controls reading and writing to the application via the sidecar. The resiliency is already set up, and that is in a different window, and I'll show you that in a sec. But everything's ready to go. All I need to do now is deploy the Java application. So that's the first one. What I want to do is I want to set up another window, and I want to split it. Split terminal. There we go. So we got 2 terminals running down here, and then what I'm going to do is I'm going to have another Ubuntu window running up above it. And this is going to be the resiliency. So over here, we're going to have the pods on and off. And then we're going to actually have the application running on this window. All right, so 3 different things we're doing here. So the first thing I want to do is get the logs. And I want to do that over here. Fire that up. Good, went in the right place, good. And then over here in the logs, we're going to have the actual application running here. So I can do the deployment. So we need to do the CD, change the direction, make sure we got access to the pods here. Yes, we do. Okay, so we're going to apply the YAML here. Okay, so it's created this service. So what I want to do now is I want to actually get the pods. All right, and this is the Java app that I need to get. See if I copied it right. Yes, good. Okay, so we're going to get the logs in this one. All right, so it's running that. It's running. Over here, we want to get the logs over here, which is not, oh. Good, we're still on 27. Woo, this is a I got to do this as time sensitive. Okay, so that's the logs over here. So it's a little hard to see from the back, apologies. But you can see the logs over here, they're running, everything's fine. So what I'm going to do in this third window now is I'm going to screw everything up. I'm going to delete the pods, Redis. It's deleted. Now, if I go back to these, you're going to see that the circuit breaker kicks off. Circuit breaker kicks off. Hello. Should be kicking off any second. And you should see some log messages over here too with errors. Bum, bum, bum. Why is it not working? It's deleted. There we go. I think it restarted okay. This is the problem. So sometimes Kubernetes starts too quickly and it recovers without doing that. So let me try again. Hopefully this works. Redis master deleted. Come on, come on. Dum, ba, bum. Come on. There we go. So it's not writing the state, and you're getting some error processing over here. So the kube control logs on the right are telling you that it's not working, but it's going to recover in a second. So that's what it does. Kubernetes will actually rebuild that pod. It'll go, oh, look, there's some damage, and it'll rebuild that pod. There we go. So it actually starts again and starts running, and everything's okay. So it's automatically, with just that little application I have, Dapper handled the resiliency, and it handled the actual logging through Zipkin, and it handles the, Kubernetes handled the recreation of Redis and the connection, but then it just continues processing as if nothing happened. So if you have a real-world website with a shopping cart and everything, users wouldn't know that your Redis went down. If you managed to fix it in time, or Kubernetes restarts as it did here, it'll actually rebuild that for you. So that's basically the demo there. So we got to order 100, yay, okay. So that's how it works. So now what I'm going to do is I'm going to show you the actions. So that's the last part I want to show you. When you're running the sidecar, when you actually want to build this, how do you actually deploy an application to Kubernetes? You could do all the steps I just showed you here, but that's a little bit of a pain, especially manually. But what if you could just automate it so every time you push to your GitHub repo, it would automatically run some tests, which mine doesn't, but run some tests, make sure it's okay, and then deploy it out to your Kubernetes cluster for you. So let's do that part. Let me just delete this Java app. Better delete that, doesn't matter where, because I want to show you nothing up my sleeve. So there we go. Now we can close all these. And we can just have one. And we can get pods. All right, so we just got the Redis running, the replicas running. So let's go ahead and make a change to our application in Visual Studio Code, and then we'll push it up to the repo. And I'll show you the action running, and while it's running, I'll explain what the action is doing, because we still have time. We got some time. We got, plenty of time. Okay, so what I've got here, let's go with we don't need that anymore. We don't need that. We need the order processing. There we go. So we don't actually need this anymore either. So here, what I'm going to do is say, Devnexus. Devnexus. And I'm going to save this. So that error message is now going to say, Devnexus, instead of error. That's boring. And update for Devnexus. So in Visual Studio Code, it's kind of cool. It's integrated with GitHub. I've already got it in my application. It knows that there's one file that just got changed, and this file here, the actual Java application. And I can commit this, and it tells me that I forgot to stage it. I can stage it. And then I can do a sync, which basically is going to pull and push to the application. And from here, through magic, it's going to deploy out to Kubernetes. Once this is done, I'll show you how. There. See, now I'm glad I didn't do that ACR build, because that was really slow for the push of one file. ACR build, to push that up to the container would have taken much longer. All right, so basically what we've got here, I updated the application itself. This is the repo that we have, Benz quick starts. Feel free to check out all the code there. GitHub, I've got a link on the last slide too. So in GitHub, if I go to workflows, this is the actual YAML that's running right now, but let's go here to actions, and you can see the update for Devnexus. So it pushed, and automatically it's running. It's going to build the image, which is what it's doing now. It's going to use a container. It's going to deploy it to that container registry for me. And then it's going to take it from the container registry and publish it to the Kubernetes service. So how does it do that? Let's have a look. Deploy to dapper.yaml. So the deploy to Dapper is on push. So anything, this one I can make bigger for you folks because we have multiple windows. Deploy to Dapper on push. Anything in the master branch runs with this application. So that's what happened. I pushed to the repo. It triggers the actual run, which is going to do everything I just mentioned. So it sets up some envars, ACR resource group, the container registry, the cluster name for the Kubernetes cluster, the resource group that the cluster's in, the container name that we use to deploy, and the deployment manifest. So the deployment manifest is that java.yaml file that I showed you. It's with Java app and a few other things in it. I can show you that again in a second. And what it does a read-write Ubuntu latest. It logs into Azure, and I'll show you how it does that in a second, because we're in GitHub, we're not in Azure. So how did it actually know to log in? It passes some credentials. I'll show you the credentials in a sec. And then the ACR build, just the same command I showed you earlier that I did manually. It passes the container name, but instead of using v1, it uses a hash. GitHub SHA, it uses a hash that's associated with this run, and so it creates a new registry entry. And then after that, you have a deployment with read and write. It runs on Ubuntu latest, and it builds the image. Once again, it logs in with those credentials. It sets up the kube login, so it sets the context. So remember that AZ get context, so it actually knows to work with the Kubernetes cluster that we already have. And then it does the deployment, and the deployment itself is just from the registry. It uses that java.app file and deploys out. So let's see what this actually looks like in the Kubernetes cluster. Should be by now. Yeah, so okay, it's all done. So it actually built it, it deployed it. Let's check out the registry. This is a container registry. You'll see the repositories. Wait, over here. Repositories, image workflow, and this is the image workflow run. Where's the one we just did? It's not here. Oh, I think it's in the other one. Yeah, it's in demo Java AKS. Yeah, there it is. So this is the one that just got created. I'm still on West Coast time, so it's 11 a.m. This is the actual image, and the version number, of course, is this big long tag. And there it is. So in Kubernetes itself, now, if we say over here, kube control get pods, you'll see, nope, not yet. All right, should be deployed. Just a moment. It did run. Deployment, it might be still deploying. But it did, so it built the image, did the login, it pushed it to ACR. Everything looks, they got the green check mark over there, so that means it worked. This is what it looks like when it's deploying to ACR. It's a big long thing, it packages it up. And then once that's done, it deploys it. The deployment itself logs into Kubernetes, sets up the kube login, get the context, deploys the application. Yep, so it deployed the application. Let's just check on Kubernetes again. Yep, still not running. Okay. Ah, yes. Yeah, that's probably it. Get pods, name, default. Nope, still not there.
Isn't it deployed? I thought I saw it was deploying in a Java interface. I'm not sure. Is it?
There it is. Yeah, you're right. Hey, there it is. Thank you. So it's deployed, but it's not ready. So it is actually there. It deployed in the Java app namespace. The application is there, and we can see what's happening with the application. If we say, where is that? So if I go in here, I just put this, yeah, kube control logs, and I'll change this one. Oh, wait a minute. I think I know what I need to do. Namespace Java. I have to fix that namespace stuff. Oh, okay. State store is not configured. Oh, you know why? Because it's in a different namespace. Yeah, so I'd have to configure that. Yeah, but it deploys. I have to fix that. Not sure why I deployed it to the wrong namespace. It must be something in my action. Okay, I'll have to do that later. But anyway, you get the idea. So I just wanted to show you how that works. And then you have to tweak your action. So just so you know. I did want to show you one other thing here, which is basically, let's go back up here. We still have a few minutes. So in settings, those credentials are automatically created by, if you go into action secrets, those are automatically created by a process there. And I can show you the process as well. If you go into Kubernetes, the cluster, there's a thing called automated deployments. And as you can see, it's in previews. It's not working just right all the time. I'm going to blame that. And I can create a new, what it'll do is it'll actually create an action. So that's how I created that action. It actually authorizes Benz. So let's say this one's called Devnexus. My repository, so I'm going to pick a repository here. And it's just called Quick Start. This one. So what it'll do is it'll go out and it'll grab the repository that I want to use, and then you specify an image. So in this case, you choose the Docker file you want to work with in that repo. And in this case, we have a Docker file. It's in state management Java. Oh boy, where is it? Hold on. Let me check and see where it is. Where is it? State management Java SDK. Okay, yeah, it's in the state management. Java SDK order processor Docker file. There it is. All right, and then I can do a Docker file build context. It's just going to use the build we have. I can create the container registry, or I can use one we already have, which is Java to AKS. As you can see, I have a few, and I don't know why they don't put them in alphabetical order, but demo Java AKS. There we go. And then the registry image I want to use is demo Java AKS. Next to deployment details, and I can use a Helm chart or Kubernetes. In this case, I am going to choose in the same state management, Java, SDK, order processor, deploy, Java YAML file. And yeah, I'd have to set up the namespace for this, which I didn't. I think that was my fault. I didn't set up the namespace for this. And then the namespace you're going to use should be Java app, but default. Let's go with that. You review it, and then what you do when you hit this button, what it does is it actually takes your credentials from your login. It creates what's called a service principal, and then that's what it's doing. Here's provision permissions for GitHub Actions on ACS and AKR, and it's going to do another push out there. So it's going to trigger that same job again, and just give it a second. It's going to tell me I can handle a push control. It already did it, so I don't need to do it, but there we go. Approve a pull request. So a PR has been generated with this new action. So then you say merge the pull request, confirm merge, and that's the same as doing a push. So that means if I go back in here, there are now two actions which are running, and they're both going to deploy out to that Kubernetes server. But you wouldn't normally do this. Normally what you do is do a test so you would catch problems like my namespace problem, and then you do it that way. But yeah, both of these will deploy, but they might not run because they might not have access to Dapper. So, but that's the way you sort of set up your whole workflow. All right, so we got 9 minutes left. I can take questions, and I did want to show you the slide. So that's basically how the Kubernetes works. It works with the containers that do the sidecar management for you and an operator. And then the sidecar itself works with your application. And you've got input-output bindings which connect to Kubernetes in this case, and or state stores, in this case Redis. And you can do things like PubSub as well, which manages large, high-volume queuing of applications and things. And there's the links. That's the link to my repo with all the code that I showed you today, including those different steps. And some links also to tutorials on Dapper and on Azure that'll give you more info. And then if you want just info on Dapper itself, that's at Dapper. So, or dapper.io is too. So we got about, 7 or 8 minutes left. 8 minutes. So if you have any questions. I'm sure there's questions.
Do you know by any chance how the sidecar injector works?
Sorry, what's that?
Do you know by any chance how the sidecar injector works?
The sidecar injector, it's magic. No, it's, so yeah. So basically, the key to that is this command that I showed as part of the manual one. So instead of running, so what you do is you build your Maven, you add the Dapper dependency, and then where is it? Instead of saying Java jar running, you say Dapper run. So the Dapper init itself creates 3 containers. And it creates a sort of runtime inside your application when you do the Maven build with the Dapper dependency. So the Dapper dependency accesses, locally, it accesses these containers. So that accesses Redis, Dapper's all the runtime running in this container, and then the Zipkin that you have for tracing as well. And that's where those logs came from in Kubernetes. So, and then when you're running on Kubernetes, I had to run all those extensions that you saw there. So what it does is it basically takes this local capability and it creates extensions which run in containers on Kubernetes. So that's hopefully answers the question. But yeah, that's basically, and it's all open source, by the way. So the Java code and everything is available at this GitHub repo here.
Yeah, because that was like usually if you have a pod with multiple containers, you just specify the containers.
Yeah.
And I think in your deployment file you didn't do that. So
Yeah.
does it just it before applying it, or do you know it?
Yeah, well, you set up those extensions, and then you deploy. So the extensions themselves, so if we look here, this is the repo for Dapper. I haven't been in here for a while, so no. So this is basically the protocols and things that run, and as I mentioned, they run in Java and several other applications. But that's basically what you're running as a sidecar. When you build the application itself, yeah, so you do the Dapper run, and then in Kubernetes, that's why I had to do all this other stuff. So normally just to create a Kubernetes, this is all you need. AZ, AKS, create, you're done. Of course, install the kube control and get the credentials, but then you're done, right? You start deploying applications. But in this case, what I have to do is provision Dapper on Kubernetes, and to do that, you have to say AZ feature register, and it creates a container service inside of Dapper. Inside of Kubernetes. And this is something you have to do. There's different ways to do this with generic Kubernetes. I'm using the Azure CLI to do it inside the AKS. And there's documentation on how to do it with generic Kubernetes or AWS or anything else as well. So AZ feature list, in this case, that just checks to see if the feature's been installed. And then you have to register a namespace and container service. And then you add an extension, which basically, this is a Kubernetes extension, which allows you to install extensions. And then from there, you say Kubernetes install this extension and with this cluster resource group, and the name is Dapper, and there's a extension type of Microsoft Dapper, and this takes a long time to install. So it's actually setting up a bunch of containers and things on Dapper. So just like Dapper init on the local machine, that sets up the containers for Redis, Zipkin, and Dapper. This sets up all the containers for the Kubernetes service. And if I say, that's what this is here. It gets it sets up all of your, the Sentry, the sidecar injector, and then if I go here, there's more. If I say Dapper status K, so there's a placement server, there's a Sentry, which just basically pings via gRPC, the sidecar injector, a dashboard, and an operator. So the operator is how you actually add your bindings, and the sidecar injector is how you find the Dapper applications from your main application. So that's how it works. There's a lot more detail, of course, but that's more like a Dapper session, and yeah. So, all right. Any other questions? All right, well, thanks. We got 3 minutes left. If you want to have any questions later, just come on up and I'll be around. So I'll be at the Microsoft booth too if you have any questions. Thanks.